Hello everyone, and welcome back to another episode of Math with Dr. War. Today we're going to look at word problems that involve angles of elevation and depression. Now, when you have to solve these types of problems, you're going to use SOHCAHTOA. Now, let's talk about where is your angle of elevation and where is your angle of depression. The easiest way to think of angle of elevation is if you have to look up at an object, while angle of depression is if you have to look down at an object. Another useful fact for you when you're solving these problems is that the angle of depression is the same as the angle of elevation. So here x is equivalent to y. And I'm going to prove that to you. So I'm going to draw a right triangle right here. And I'm going to say that this is 50 degrees. Now, if this is 50 degrees and I have to find x, I know that all the angles in a triangle sum to 180 degrees. So in order to find x, I would take 180 and I would subtract 50 and I would subtract 90 and I get a value of 40 degrees. So x is 40 degrees. Now suppose I want to find my angle here, which is the angle of depression. Now remember your complementary rule? So right here, these two angles sum to 90 degrees. So if I know this is 50, I can go 90 minus 50 and guess what I get? 40 degrees. So x is 40 degrees. So notice this and this are equivalent. So my students, when we did this in class, they never liked solving angle of depression because the angle was here. So I simply told them, whenever you get the angle of depression, write it as an angle of elevation, problem solved. Let's look at some problems that involve angle of elevation and depression. A key thing to solving these problems, the first step would be read carefully, draw a picture, and know your SOHCAHTOA. Now, let's look at the first question. A 20-foot ladder rests against a wall. Its angle of elevation from the ground is 55 degrees. How far from the wall is the base of the ladder? So my students always complain that they can't draw, so I says, you're drawing a right triangle. So just draw a right triangle. Now we're going to label everything. Now we know that it's a 20-foot ladder. Now this was a big hilarious joke in my class because I asked them which side was the ladder and they were telling me it was this side here, the opposite, and I nearly died. And I said to them, where do you put a ladder? So here, this is your ladder. So your ladder here is 20 feet and it rests against a wall. So here's it resting against the wall. The angle of elevation is 55 degrees, which is here. And how far from the wall is the base of the ladder? So this is the wall here, and they want to know how far from the wall is the base. So where's your base at the bottom? So that should be a clue that there's your x. When I look, I have adjacent, and I have hypotenuse, and I have my angle. The only trig function that uses adjacent and hypotenuse is cos. So I know that cos of x equals adjacent over hypotenuse. Therefore, cos of 55 degrees equals your adjacent, which we're trying to find, and I labeled it as x, over 20. Now I'm going to cross multiply, so I get x equals 20 cos 55. I'm going to put that in the calculator, 20 cos 55. And I'm going to round my answer to one decimal place, so it's going to be 11.5 feet. That is the distance from the wall to the base of the ladder. I have a blimp that is 4,280 feet above the ground, measures an angle of depression of 24 degrees from its horizontal line of sight to the base of a house on the ground. Assuming the ground is flat, how far away along the ground is the house from the blimp? So again, draw a right triangle. Now a blimp is like a plane. So I'm going to draw something here. So that's my blimp. So when they say that it's 4,280 feet above the ground, they're talking about the vertical distance. There's your 4,280. The angle of depression is 24 degrees. So that's here. But remember, if you get the angle of depression, we can write it as an angle of elevation. So that's 24 degrees. Now, what do they want us to find? Now, assuming the ground is flat, so that's the key thing, we're going to the ground. How far away along the ground, again, is the house from the blimp? So we're finding X. So we're finding the adjacent. So what do we have? We have the opposite, we have the adjacent, and we have our angle. Who uses opposite and adjacent? Tan. So tan of X equals opposite over adjacent. So tan of 24 equals to 4,280 over X. Again, let's cross multiply, so I'll make that a fraction. When you cross, you get X tan 24 equals to 4,280. And if I have to solve for X, I need to divide both sides by tan 24. Therefore, X equals, and we're just going to put that in our calculator. So 4,280 divided by tan of 24. So if we round again to the nearest tenth, so our distance is 9,613 feet. Suppose a tree is 15 meters in height, casts a shadow of length 27 meters. What is the angle of elevation from the end of the shadow to the top of the tree? So again, let's draw a right triangle. So suppose a tree is 15. So the vertical would be the height of the tree. So here's 15. Now where do shadows go? They go on the ground. So here's will be 27. And they want the angle of elevation. So here's X. Again, who uses opposite and adjacent? That would be tan. So I know that tan of X equals 15 over 27. Now I need to find X, so I'm going to have to do the inverse tan. So X equals to the inverse of tan, 15 over 27, and get our calculator. So second function tan, and I'm going to put this in as a fraction, so I'm going to use n over d, 15 down 27 to the right, close the parentheses, enter, and again I'm going to round this to the nearest tenth. So our answer is 29.1 degrees. Some problems, again, read carefully, and some of them you might have an additional step. So we have Allison is looking at the top of a tall building. Her eyes are 5 feet above the ground. The angle of elevation is 75 degrees, and she's 15 feet from the building. How tall is the building? So again, I'm going to draw a triangle. Now they said that the angle of elevation is 75 degrees, so that's 75. Now they said that her eyes are 5 feet above the ground. So here is Allison, like that. And Allison's height is 5 feet. So that's going to be important. So there's Allison. She's looking up at this building. Her angle of elevation is 75 degrees. And she's 15 feet from the building. So from here to here is 15. And they want to know how tall is the building, which is over here. So what do we have? We have opposite and adjacent, and that is tan. Therefore, tan of 75 degrees equals X over 15. If you cross multiply, you get X equals 15 tan 75. So 15 tan 75. Okay, so you see your answer here on this calculator, which is a TI-30XX Multiview, is 15 radical 3 plus 30. We actually want this as a value, so we're going to press the toggle function here. And notice it gives us a value of 55.9. And again, I'm always rounding to the 10th place. So this will be 56. So X, which is the height over here, is 56. However, We're talking about Allison, and she's looking from her eyes, and she's 5 feet tall. So we have to add 5 feet to the 56 to get the actual height of the building. So if you take 56 and add it to 5, the height of the building is actually 61 feet. So please be careful when they give you the height of the person, and in the problem they tell you that the person's height and how they're looking at the object, because Allison's height is going to come into play. I know my picture doesn't really show it, but we want the height of the building. So the building is a little bit taller. What we found X was the 56 because this is Allison looking at the building. So 56 plus the 5 gives you the total height of the building. I hope these examples have been helpful with understanding the angle of elevation and depression. And again, please like, please subscribe, and please share. Have a great day.